In problem 3, we are given 3 different graphs that all show us the number of people who watched a TV episode as a function of that show's episode number. So in other words, our input is episode number and our output is the number of people who watched. Now the first thing I want to point out in this problem, because I actually almost missed it the first time around, is that these y-axis numbers are different on each graph. So we're going to have to be very careful about paying attention to that when we go through these problems here. But our goal here is to match one of these descriptions to one of these graphs. And there's one description that doesn't fit with anything. So first one we'll check out. Description A. This shows a good core audience. They had a guest star in the 5th episode, and that sounds important. They brought in some new viewers, but most of them stopped watching after that. So looking at our graphs, one graph that I noticed right off the bat is graph C around episode 5 has this big jump in how many people are watching it. And they seem to have a good core audience, right? Not a lot of change here, and later on, not a lot of change again, of around like 2.5 million people. So this definitely seems like it's graph C. Description B. This show is one of the most popular shows and its audience keeps increasing. Well, right off the bat, I noticed that on graph A, the numbers keep going up and up and up, right? These are just increasing. But these numbers are really low. This is less than 1 million people watching at the beginning, and that's much lower than show B or show C. So this one I don't think has any match. Description C. This show has a small audience, but it's improving, so more people are noticing. That sounds like show A now, right? Again, we're increasing in popularity, small audience to start, but we're going up. So that's graph A. Description D. The show started out huge, and even though it feels like it's crashed, so it means, see, we're going down a lot, it still has more viewers than another show. So started out huge, started with 10 million people. We're going way down, but we still have, even way over here, around maybe 3 million people. So this is definitely show B. In the second part of this problem, we're just asked to say, hey, which is the biggest? A of 7, B of 7, or C of 7? So in other words, which one of those has the biggest output on episode 7? Or which one has the biggest audience on episode 7? So A of 7 looks like it is about 1.7 million. B of 7 looks like it is about 3.5 million. And C of 7 looks like it is about 3 million. So it looks like show B has the biggest audience on episode 7, right? And that's exactly what B of 7 being the biggest tells us. That is the biggest audience on that episode. The third part of this problem asks us to just now sketch a graph for the one that we didn't match up in part 1. So in other words, sketch a graph for description B. So this show is one of the most popular shows and its audience keeps increasing. Well, if it's one of the most popular, I'm going to steal the y-axis from show B, which is really, really popular. So I'm going to go 2 million, 4 million, 6, 8, 10. And if it's one of the most popular, I don't want it to start out really, really high because it has to go up from there. So I'm going to start it out right around 3 million on episode 1. Oops, sorry about that. 3 million on episode 1. And we'll just kind of go up slowly from there. So episode 3, episode 4. And now we've got our show that through 10 episodes just keeps increasing and is one of the most popular shows.